Good evening, everyone. My name's Rohit Bakhshi. I'm here to represent the engineering team of Galaxy. And what we've done over the last few weeks is we've looked at Apollo and integrated Apollo into Galaxy. I'm going to talk about, cover these agenda items today. So we're going to start with why we looked at Apollo. So what kind of things we were doing in Galaxy, and why Apollo as a framework, what Matt introduced and talked about, made sense for us to pick up and use. Then we'll go on and actually look at some code, look at some architecture diagrams, and look at how we incrementally adopted Apollo into Galaxy in a step-by-step manner. And then we'll kind of wrap up and summarize with the learnings, what we gained, what we learned in Galaxy, and what we're excited about looking ahead to the future of Apollo and what it means for Galaxy and for other Meteor apps as well. And I'll leave some time at the end for questions. So let's start with Galaxy. I'd like to start with a screenshot. So I don't know how many of you are using Galaxy or have seen it. I'm told to use the mic. I don't know how many of you have seen Galaxy or used it. Galaxy is basically a platform as a service for running, monitoring, and managing Meteor applications. And it specializes in that, and we built it specifically to do that. So what you're looking at is one of the screens in Galaxy that you see when you first log in, and it's got a list of all the apps that you've deployed to Galaxy, and then some identifying information about them, some summary information about them. When you deployed, how many containers it's running, how many connected clients, how much CPU is being utilized, memory utilization. And so this is one of the views that we have in Galaxy. And Galaxy, the management interface that you're seeing up here is actually a Meteor 1.3 application. And we use React as the front end. And so from a kind of diving into the tech architecture, just to give you context of how we built Galaxy, it's a Meteor 1.3 application using React for all its components and its view layer. And it's a Meteor application, so there's a Meteor backend running a node. It uses DDP for all its data subscriptions. That's the way we built it. And so a lot of those things that you saw on this screen are all were all reactive, and we'll talk about that in coming up as to what we did with Apollo. And for that screen, the relevant data sources that we had, a lot of our application state is in Mongo. And then Galaxy has a whole part of it that deals with running Docker containers, application containers, schedulers, proxies, all of this infrastructure elements. And it runs that, and we build that on top of Amazon ECS, Elastic Container Services, and EC2, as well as data sources in Amazon like DynamoDB, which is a key value store that Amazon provides us to use. So on the screen, the data sources, the kind of the backing infrastructure is the MongoDB database, as well as Amazon DynamoDB. And so let's talk about what Apollo brings to the table here. And so Matt talked about this. Apollo is an incrementally adoptable, which means you can pick it up in pieces and you don't have to re-architect your entire app, data stack that manages the flow of data between clients and backends. And with that, it's another option to DDP for a Meteor application. And that's the way we approached it with Galaxy as well. The reason we looked at Apollo and the benefits that it brought to Galaxy and to other Meteor apps kind of lay out this way. So one, it allows us to, in a more seamless and efficient manner, connect and manage multiple different backends in our Galaxy management interface Meteor application. And the real benefit of doing that is that it allows us to have more complex queries, more complex joins, and GraphQL and Apollo are much better for dealing with joins across multiple different data sources. And so this is one of the areas that sometimes are a struggle with DDP as well as REST. And with Apollo, you can have one GraphQL query that you write that has one round trip between the client and the server, and you can pull from all your different data sources and get that combined result in a seamless way. And that's what's really exciting about this in the context of some of the screens and the work that we did in Galaxy. As well as there's optional reactivity. And so this is different from DDP in the sense that when you use DDP, reactivity is the default. And there are some screens where that's not as important. And so with Apollo, the approach is it's optional. And so you can kind of configure and say, I want to do polling or these things to keep refreshing the data on a more incremental manner for specific components and specific data sources. So let's look at that in the context of the same screen that I was talking about, right? On this, there is a list of applications. For each of those applications, there's metrics that are coming from. So the list of applications are actually coming from a table, a collection in MongoDB. The summary metrics and the summary information, but when it's deployed, who owns it, what containers, that all comes from Mongo as well, another set of collections. And then we have some data here like those Spark charts that show a history of how your different metrics have changed over the last 24 hours, that's being pulled from DynamoDB. So there's different data sources here that are powering the screen. And what we did with our integration of Apollo into Galaxy is actually integrate Apollo for those specific data sources and use it alongside DDP. So we have DDP for all the rest of the data sources, and we incrementally picked up Apollo. Matt introduced the Apollo client, Apollo server, so I'm not going to go over that in detail. You can have the architecture that we landed on was the Apollo client was part of the React front-end layer of the application, and then Apollo server was actually part of the Meteor backend, the node process that we were running. So it wasn't a separate instance. It was all part of integrated in to our existing architecture. And with that, we used GraphQL as the query framework and polling to be able to refresh these different data sources that I have and these different components that I have highlighted up here. And so that was the reason and kind of the benefits of using Apollo in our architecture. Now let's talk about how we actually went about building this and integrating this in over the course of a few weeks that our engineering team spent building this out. So it kind of breaks down into this set of steps. Started with thinking about and defining a GraphQL schema. And so how do you represent the backend data sources that you have in the context of how the client wants to query them and use them to render state on the UI. Once we did that, there was architectural work to actually integrate the Apollo server to be part of the Meteor backend application and server. And then to complete that, you define resolvers, which I'll talk about are the way to tell GraphQL how to actually execute a query and talk to pull data from different backends. And then you integrate with the view layer, which is React in our case. And so let's look at those steps in a bit more detail. So the GraphQL schema, so starting with our existing Mongo schema, right? So this is taking a few of the data components that we had from the screen that I was talking about. We have applications, we have activities that happen for those applications, so deploy, delete, update, add a certificate. These are all activities. And then you have container types that represent is it a 2 gig container? Is it a half a gig container? Is it a 1 gig container? These are all, you can think of as foreign key constraints between apps as your main table, and then foreign key constraints between container types and activities. And so with DDP, we had defined these as Mongo collections and different tables inside mini Mongo on the client side. With GraphQL, and we're defining the schema, and this is actually code snippets of the definition in the new implementation that we did in Galaxy. It's very similar. So defining the schema is very similar, and you can basically map what you had from collections in Mongo to a GraphQL schema. The difference and the benefit is when you start writing queries against it. And so this is an example, again, pulling from the code, doing a nested join query where if I go back to the screen and I'm looking at pulling the data to get a list of applications, summary metrics about those applications, and then get the data for the Spark chart so I can figure out what 24 points need to be put onto the screen to represent the values over a 24-hour period. Looks like the left side in the previous world where we were using DDP and in our Meteor application. So you iterate across all the applications in the list, and then you have different subscriptions to pull up the different types of data that you would then combine and render the UI. And so that's multiple iterations between the client and server. You compare that to writing this GraphQL expressive query where you define the fact that you want all the applications and you want, you can actually embed stuff that you want the container types, you want specific fields from those container types, you want to find last deploy activity, giving the metrics. That's one query that gets sent to the Apollo server instance that we have integrated into the backend, and then you get the results from the different underlying data sources and back to the client. So the real value here is in simpler ways of expressing and doing complex queries. So that's the schema perspective. When it came to the Apollo server, what we chose, and you can do it in 2 different ways. There are people who have separate Apollo server instances running as a separate node application or separate other runtime architecture you can choose as well. We decided to put it into the Meteor backend node process. And the way that worked out is that with the Meteor backend, we listened to communications coming from the external world on HTTP and HTTPS, so port 80 and 443. And then there was a endpoint GraphQL that actually routed to the Apollo server instance and the port that it was listening at. So it wasn't actually available directly. It's proxied through communication coming on port 80. And the way that looked in the code that we built for Galaxy is that we had GraphQL service running in the Express runtime inside the Meteor backend, define the endpoint for GraphQL, put in place a proxy that routed requests coming in to the GraphQL endpoint to Apollo server to resolve the GraphQL queries. And then we also were able to integrate authorization that we got from Meteor accounts, so into running the queries and resolving the queries that were running in Apollo. And so we didn't lose any of that stuff that we had with DDP. You can do that all with Apollo integration as well. There's a very good GitHub project called the Meteor Apollo Starter Kit that's available online that has all of this as kind of examples and a boilerplate. And the Galaxy code actually looks very similar to that. So if you want to go and integrate this into your Meteor application, that's a great resource to go look at and learn about how to do all this stuff. So next step is to define and define how your query is actually going to be parsed and going to go call different backend sources. So we defined a resolver, which is a function to figure out how to get the value of a field in any query that you send to the GraphQL server. We defined resolvers for all of these different fields that we used. So these are all the different fields that were part of rendering that UI screen that I showed before. And to go back to code, an example of what this looked like. So I talked about the GraphQL schema and then defined the resolvers. And you can see here that we're actually calling the Mongo interface to get data from a Mongo table for the users. And then during development, our engineering team used mocks in all the resolvers to be able to do testing and generate, use factories and generate data. And so this is, again, kind of a general approach that we use in all the resolvers for the different fields to complete the server implementation. And then let's talk about how this plugs into the view layer. So with Galaxy, I talked about we built on React and we built with Meteor 1.3. And the front end approach, the architectural approach that we took was this idea of using presentational and containerized components. And this is something that Dan Abramov has written about online, so you can read more about it. The idea here is that you have two different types of UI components or UI classes that you create, JSX files in the React world. One is a presentation component, and that's where you put all your visual code. So those components are strictly about how you render things on the UI. They become reusable because they don't store any app state or data state or user state in the components themselves. They actually get state passed into them from a parent component, and that parent component is the container component. So using this architecture approach, you have visual components that are just tasked with rendering and defining how layout looks for a component, and then you have container components that are kind of like your view controller components that know how to pull data from different sources and pass it to the UI to then render and create. And because we had structured our front-end code in this manner, when it came to integrating Apollo, the work that was there was all it took was working with the container components and pulling out for those specific component instances that we had on that screen that I talked about, that I showed you before, pulling out the DDP logic to talk to Mongo directly, or to Minimongo and Mongo directly, and put in Apollo in its place. And so what that looks like is, on the left is an example of a presentational component which is just dealing with the visual aspect and the layout. And on the right, you have the way that we load data using a GraphQL query that's being run and executed, and then passed to the app item presentational component. And so that separation of concerns helped us swap out DDP from these specific container elements and swapped it in with Apollo. And that's kind of an overview of the different steps that we took, and can be taken with any Meteor app, really. And so there's resources online to help outline how to do that. And one thing I wanted to call out was that during development, we extensively used GraphQL. So this is something that Matt also talked about. It's an open source tool, and it's really like a query explorer for GraphQL. So once you have your Apollo server, GraphQL server stood up, and you have an endpoint ready, you can actually issue queries on the left, write different queries, and explore the schema, explore your different APIs, explore your different backends, and see results coming back on the right side. So it's a great tool to run and use in development to see learn about what's going on in GraphQL and how it works, as well as validate that you have the right data coming through and what your UI components are going to get that they then have to render. It's a great debugging and development tool. And so in summary, as we looked at this, there were clear benefits to Galaxy and I believe to other Meteor applications of using Apollo, especially around being able to do a lot more with your data, because it's much simpler to write queries that span different data sources, complex queries as well. And then from a performance perspective, it's nice to have the option to have optional reactivity. So there's some things that are benefited from reactivity, from being reactive, and some that don't need that constant CPU usage on the back end and the front end to do reactivity. And so that was a good benefit of why we looked at Apollo for those screens in Galaxy. The implementation approach it's incremental. You don't have to re-architect and throw away your client code, your front-end code, your back-end code. It can be incrementally adopted. You can choose specific UI components, specific screens to bring Apollo in. You don't have to do it wholesale. And that was very powerful, and that allowed us to make incremental improvements. We're looking forward to doing more in Galaxy as well. And finally, for Apollo as a project, there's a really exciting future ahead in terms of features, in terms of maturity, that will bring more and more to multiple different types of applications and Meteor applications and to Galaxy. And so we're really looking forward to that. Galaxy is in production today. It's being used by thousands of people, and we're putting Apollo in it now. So there are UI components and views that are ready for Apollo and production usage in Galaxy. We're looking forward to more features. It's interesting, the batching functionality that just went into Apollo came from some of our investigations and explorations of building some of those screens and running multiple queries together on one screen. And kind of learned about the fact that we need to batch them together so that's more efficient instead of having multiple different queries go across the client and the server. And so that came from, now Apollo has batching built in. So that was a nice interaction and kind of joint learning together. And there's more to come around how to control reactivity, specify for fields that you want a certain polling latency that's lower than others, and so you can kind of control how performant your application is and make those trade-offs between architecture, resource usage, and responsiveness of the UI, as well as looking forward to WebSockets as an option instead of just polling over HTTP. And so, if you want to get started, encourage you to go check out apollostack.com and the associated GitHub account. There's a lot of starter applications. There's a repo on Meteor Apollo Starter Kit that's very useful and came in great use for the Galaxy team as well. And if you want to use Apollo in production, an app that's using Apollo in production, you should go sign up for Galaxy for those who haven't. It's a great hosting tool for Meteor applications. Thanks. And open to questions for Sashka or I. Yes?
So you're storing the stats in the database, right? And pulling those to the client?
So
From the Galaxy dashboard.
yes. So the question, is that the question or?
The question is, Docker comes with a native stats API that can stream that straight to the client. So wouldn't it be easier for you to just stream that straight to the client rather than storing it in your database?
That's interesting. So the question is, we're talking about stats on container metrics, CPU, RAM, and what we're doing in our architecture is that we're actually writing those to Dynamo, which is a key value store, scalable key value store. And your question is, since we're using Docker, Docker has an ability to stream these stats to clients as well. Just from my take, and maybe you can add in, from architecture's perspective, there are thousands of containers running, and there's not clients that are waiting to read that state of them at all times. So because a lot of those stats are also historical. So they're going back over 24 hours, 7 days.
So follow-on question.
Yes.
You're storing the logs as well?
We are storing application logs as well, yes. So if you look at, there's an interface in Galaxy where you can actually see application logs for your application containers.
Okay, thank you.
Sure. Yes.
So I would imagine that there's probably a lot of Meteor apps out there floating around that have this sort of n+1 query problem, right? How much did that impact performance, and at what point did you figure that out? I mean, I guess my concern would be, when does scalability become impacted by that type of design?
Do you want to take this?
Sure. I guess the question was, there are a lot of Meteor apps out there that have a similar n+1 query problem, which I think is related to doing something like a client-side join where you load a bunch of items and then a bunch of dependent items of the data you just loaded. And the question was about how that impacts scalability. I think, when you need the data, you need the data, so you have to load it somehow. So whether you load that data through GraphQL or through Meteor, you're still loading kind of the same number of objects. So I wonder if there's like a more specific scalability.
The GraphQL was precipitated by the fact that you had some performance issues around this issue of going over the wire a couple times. Did that happen when you got to 1,000 nodes out there, or 500? I mean, what point did that become a problem?
Yeah. So the question is about why did we kind of decide to solve this problem now? Whether it was a scalability thing or something else. And I think it's not about scalability in this case. It's about the user experience of the application. So the biggest problem about doing client-side joins is that you end up doing many round trips to the server, which is not terribly bad for the server, but it means that your UI loads in stages. So in the previous version of this page, you would have the list of containers show up, and it would be relatively blank. And then after each container had loaded, it would then load its own stats and its own metrics. And so those would pop in later. And so that means you have to do at least 2 round trips just to get all the information. The best part about doing this with GraphQL is because you can send these nested queries, they load all the data in 1 round trip, which does the same amount of loading on the server, but on the client it's much faster because you don't have to wait for the first set of data to arrive before sending the second query. And this is a problem that's common to basically all applications out there, whether you're using a REST API or using DDP with Meteor or anything else. And people often solve this by having customized endpoints that return nested data. And that's also can become a problem because you might return too much data. You might have different parts of your UI that need different nesting of data, and now you're making like dozens of endpoints, which is something that a lot of people end up having to do.
Yes.
I'm wondering what this. I saw something mentioned online about Android client or iOS client for Apollo, and I was wondering what the status of those are.
Yeah, that's also could be a question for me. For context, I'm the tech lead on Apollo. Rohit's working mostly on Galaxy. So the question was, there's some stuff online about future clients for GraphQL or for Apollo for native Android and iOS apps. I think that's actually super exciting. For context, Facebook invented GraphQL several years ago, 3 or 4 years ago, specifically to use it in their native mobile apps. So it's kind of funny that that's one of the biggest things missing from the GraphQL community today. We're starting to work on some basic native client implementations. Specifically, the thing we're most excited about right now is strong typing. So in JavaScript, it's not as big of a deal, but on native apps, you're usually using a strongly typed language. And one of the benefits of GraphQL is that it's also strongly typed. So this means that you can have a GraphQL query and you can know what types it's going to return before you even send the query. And so you can generate code that will let you have all the typing information in your language that you're using to develop your mobile app. So that's the first part we're going to work on in the coming weeks, is basically a way to do GraphQL queries just as HTTP requests, but they will return you typed data that you can use in your application. But I guess one thing that's prudent to mention is one huge advantage that GraphQL has, at least the current implementation, over the Meteor data system before it, is that the simplest GraphQL client is simply something that sends HTTP requests. So just to load data from your server, you don't need a special client. You can just do an AJAX request using jQuery or Node or whatever you want that just sends a GraphQL query string and gets back a JSON blob. So if you have a server with Apollo, you can load the data in a native mobile app today. It won't be like the best experience ever, but it's super easy to get it to work.
Like we're running short on time, so I'll be around if you have any more questions. Thanks.